Welcome to the Construction Show. I'm your host, Jerrod Downey. Today we have back on the show, Narain Hariharan. I had your name right, Hariharan, right?
That's right.
Yeah.
Yep.
He is the new product and application manager for Graymont. Last time you were on, it was engineer, not manager. So you've been upgraded.
That's right. Yeah.
Are they keeping you busy?
Of course. Yeah.
Okay. We've got so much like technical information, but there's so much going on at Graymont right now. So can you just give us the bird's eye view of just anybody who doesn't know Graymont, just in general? But then also, I know you're coming in with a lot, so maybe just a bit of a summary of just some of the key, because we're actually jumping sectors a little bit. We're talking some mining, construction. Can you just give us an overview of what we're going to be covering today?
Sure. Yeah. First of all, Jerrod, it's good to be back. And it's exciting times indeed for Graymont. So Graymont is a privately owned company. We've had operations for more than 75 years across North America and Asia Pacific. Graymont's a global leader in lime and limestone solutions. And I mentioned about the exciting times for Graymont is specifically branching into low-carbon cementitious binder solutions. And that's what we're here to talk about. We had our first couple of episodes with you, introducing and talking more about Graymont and what Graybond is. So the new products, the new product family of products is what we're calling as Graybond, or Graybond family of binders for mining and construction applications. And that's what we're here to talk about and take a deeper dive into today. So we only introduced some of the basics of Graybond in previous episodes, and I think I'm looking forward to talking more about the progress that we have made in terms of working with several folks from the industry, partners, collaborators, engineering firms, contractors, advancing our work from the lab to actually get out and do the field validation trial. So we'll touch on both our progress in the mining applications as well as construction, construction specifically focused on soil stabilization today.
And within both those, so it's going to be mining, construction, and that's with those we've got different results specific to those applications, right?
Yeah. Every application is unique and nuanced, has different set of performance requirements that you need to meet. And we're here to talk about the details of what's involved in each of these applications. So the development of Graybond is different and unique for the different applications.
And you've had there's been a lot of trials now within different applications. Do you have sort of some basic numbers of what you've seen in terms of lower GHG, like those types of things?
Absolutely. So the value proposition of Graybond is built around a few key elements. First, of course, we want to make sure that the product works. So performance is the key, making sure that we meet all the performance requirements of the project. The second is making sure that security of supply, making sure that we have a stable and reliable security of supply. And especially where cement and SCMs, supplementary cementitious materials, are in short supply in certain markets and applications. In terms of greenhouse gas benefits, particularly like you asked, Jerrod, it can range between 20 and 70% reduction in the Scope 3 emissions of the end user. So how we do that is the two ingredients in Graybond. If you compare it with traditional cement or cementitious binders, natural pozzolans and limestone fines have a very, very minimal greenhouse gas footprint, and then you have lime, which would activate the natural pozzolans and also work to provide the calcium that's needed to form the cementitious products. So overall, you're looking at 20 to 70% reduction in carbon footprint.
And why are they lower to produce?
Lower to produce? You mean to manufacture Graybond?
Yeah. Just the emissions.
Yeah. So you think about it's a combination of two factors. It's the lowering of the GHG emissions is a combination of the raw materials, the ingredients that are used to manufacture Graybond. In terms of manufacturing itself, there is no calcination outside of what's used to produce lime. And our manufacturing process is pretty simple. It's about milling, the raw materials to size and blending them in optimal proportions. So
let's talk about our Heavy Industry World Tour, brought to you by Savannah Equipment, supplying mining equipment worldwide, and Corporate Traveler Canada, helping companies travel the globe simpler, faster, easier. We are heading to events across North America and Australia and filming episodes on location. Email us at info@crownsman.com to be part of Crownsman's Heavy Industry World Tour. In the demanding world of mining, safety and performance are paramount. Sophie is a comprehensive solution built for the unique needs of the mining industry. From the ground up, their technology helps everyone who works in, manages, and leads mining operations to create high-performance work environments and ensure they come home safely every day. Create the workplace everyone wants to be a part of. Choose Sophie. Visit sophie.com to learn more. Effortless Corporate Traveler Management is here with Corporate Traveler Canada. Boost your business with trusted expert solutions that save time, money, and enhance the traveler experience. Trusted by thousands of companies worldwide. Book and track your travels on your phone or let your dedicated consultant handle it for you. Enjoy 24/7 support and live chat from any time zone and get real-time travel alerts anywhere you go. Your next business trip just got easier. Learn more about Corporate Traveler Canada at corporatetraveler.ca.
It's just I'm not in the space. So is it?
Yeah.
There are just less levels of processing.
Correct.
To get it to ready for market.
Right. Yeah.
And that's
less levels of energy consumed compared to traditional.
Right. Okay.
Cement. Yeah.
Let's jump in right into a couple different applications because we want to talk. I think we're talking. We've got field trials. Because your team provided me with some notes here that I wanted to jump into. Let's start with the mine backfill.
Okay.
Can you kind of lay the landscape of what we're talking about?
Yeah. So mine backfill is a critical component in underground mining operations, modern underground mining operations, wherein the operators use a cement or a cementitious binder to treat the waste rock or tailings and fill the stopes, which would enable them to enhance the ore recovery and also minimize surface disturbances such as tailing ponds. So in a gist, that's what mine backfill is. And our goal with Graybond is to have an alternative for the cement or cementitious binders that are used in these systems.
So in these backfill systems, what have you done comparisons of what kind of reductions you're getting in that specific application?
Yeah. So that is the process that we're engaged in with several mining operators throughout North America. So every mine is different. The performance requirements are different. The goals are different. Our objective is to make sure that we meet the desired, end goals and also address directly the pain points of the mining operators working closely with them, right? So in terms of cement replacement, we're looking at anywhere between 35 and 50% cement replacement in the case studies that we've done so far, and that includes both lab studies, internal and externally validated, lab studies, and also field trials, right? So based on the proportions of the Graybond binder that we use typically for mine backfill, we're seeing anywhere between 30 to 50% reduction in the greenhouse gas emissions.
So when you're saying, but the 30 to 50%, or 30, do you say 30 to 70%? That means of less cement being used and using a Graybond?
Yeah. So there's two components, right? So the reduction in greenhouse gas footprint is going to be determined by how much cement you replace,
right?
How much cement or incumbent binder that you replace. In certain instances, the incumbent binder is a combination of cement and slag, or some other system there. So the amount of cement or the incumbent binder that you replace, and number two is also the formulation of Graybond that you use is also going to play a role in the reduction. So I present numbers that are broadly in a range. You'd notice that I mentioned 30 to 70%, 30 to 50%.
It is quite a range.
It is quite a range.
Understand
so that is where we're working on developing the LCAs and also EPDs, environmental product declaration documents for Graybond, and that will actually give us more of a accurate estimations.
How do you go about these though? Do you get like are there third-party companies, like organizations that'll come in and do the testing for you to really make sure that your numbers, you're getting it, obviously that it's accurate, but also sort of informs you of where it's at as a product in the market?
I mean, you're asking about the greenhouse gas footprint or performance like strength?
All the above, yeah.
Yeah. Okay. So, we do work with third-party engineering firms and consultants for determining the strength in situ. After the trials, we sample materials and go back and test the strength. So we rely on external engineering firms for that. We also have in-house capabilities, but we want to make sure that and the mining operator would have the same expectation that said that the results are independently verified. So that's where the additional credibility comes into play. And with regards to greenhouse gas emissions, we're working our HSE team is working with external consultants to define the GHG profile of Graybond, and that has to be application specific, and also depends on where we produce Graybond and what goes into the production of Graybond. So that's a pretty thorough analysis.
Sorry, what do you mean by that? What where you produce it?
Yeah, I mean, so Graybond produced at location A, and location B is going to have some differences.
Right, I see.
Depending on the production practices, that type of equipment, and all those.
Right,
things.
so you're matching up production practices to application, and it's always there's a process there that always has to happen.
Correct. Yeah.
Right.
So it has to be a site-specific, project-specific analysis.
Join us in the depths of the mining world, where global leaders and industry giants converge to shape the future of mining. From groundbreaking technologies, advanced machinery, revolutionary safety measures, to sustainable initiatives. This is the voice of mining. This is Mining Now. Showcase your company to millions worldwide. Book your episode now. Visit crownsman.com. Dive into the thriving world of agriculture with Agriculture Now. Join us as we explore the past, present, and future of this vital industry. Discuss your expertise behind thriving crops, breakthrough technologies, and the visionary minds shaping our fields. It's your time to be the voice of agriculture. Reserve your spot today. Email us at info@crownsman.com or visit crownsman.com.
And then, okay, so can you walk us through because you did field trials in 2023? You did one?
Yeah, so
walk us through just that process again,
Sure.
because it's one of those things. I mean, obviously, your team has been in it
yeah,
years now, but
that's right.
For us, it's all new. So, can you just walk us through what one of those trials looks like?
Yeah, sure. So the R&D development of Graybond binders started out for mine backfill applications about 5 years back. And
That was the original sort of concept.
That was the concept. That was the primary target market application.
Okay.
For Graybond, and then we've branched out to other construction applications,
Right.
and customized our formulations for soil stabilization, and we're now looking into low carbon concrete mix designs and how we can fit in there. So just going back to the timing and how this evolved within Graymont. So the started about 5 years back. The first 3 years were mostly focused on internal R&D, and then like in 2023, like you mentioned, we worked closely with a major mining operator in Western U.S. They had a cemented rockfill system where they use cement to treat their rockfill. The rockfill is one of the types of backfills, that you typically encounter. The other one is a paste backfill. So in this instance, it was cemented rockfill. And our goal was to, they were facing supply issues both for the cement, and in some instances, they were using a combination of cement and fly ash, and facing some supply shortages. So our goal was to identify how much of the cement can be replaced with Graybond. And that's where the field trials happened on the basis of the information that was gathered through both our internal and externally validated lab trials. So our first trial with the operator was in late 2023, where we targeted a 50% cement replacement. Had mixed bag of results. We were able to meet the long-term strength requirements of the project, but the rate of strength gain with Graybond was slower compared to cement.
Because it takes longer
it's just
a longer curing process. Right?
It's based on the mechanism of how Graybond works,
but
and
then
also
much but it strengthens over time.
Yeah,
as opposed because cement hits its peak at what, like it's like 6 months or something, right? It's its max strength.
Cement achieves 90% of its lifetime strength within 28 days.
Oh, 28 days.
Yeah,
okay.
yeah.
Even shorter than I thought.
That's
yeah, okay.
right. So that's right.
And then it basically starts, which was a
tapering
horrible thing,
right.
by the way, to find out when I just bought an apartment.
Yeah.
But yes.
Too much strength is not always good, right? I mean, you want the optimal levels of strength. You don't want to, too strong of a building that's going to be brittle and fail, right?
Okay.
So, yeah.
Well, thanks for making me feel better. I think I could handle a little bit of a stronger building, but anyway. So when you're talking about those results, then, it took because it needed to cure faster. I'm just trying to understand that it's quite an interesting thing. So.
Right.
The standard cement, within 28 days, it's going to be its maximum strength.
Yeah.
Your product's going to take a little bit longer. So there was that adjustment then that needs. What is that adjustment?
Right. So it was our first trial, right? And it's a process of working to making sure that we understand, what types of raw materials are being used, in the field, understanding better about the cemented rockfill system. So trial one, we were, and the fact that, lime and pozzolans, result in a pozzolanic reaction wherein the kinetics of the reaction and the strength gain is typically slower compared to cement. Now, what we do and we refined from there and adjusted our formulations, and that's where we worked on the second trial. We did see positive results in the first trial. Like I mentioned, we were able to meet the strength targets at day 28. But day 7, there was another target which we fell short of cement. And that's where the work, it's very much
something sorry to jump in, but it's something I'd never think about, that it's like, if it's stronger, that's the end result to me. But of course, there's also a timeline because you're in an active mining operation.
Correct. Yeah.
Right. So they actually
there's strength targets that you need to meet over time. And we were able to do that in the second iteration. So, and the second trial, that was in earlier this year. That study concluded in March of 2024, and we targeted a 35% cement replacement, and we hit both the early and long-term strength targets, and pretty much we received a very positive feedback from the mining operator, and here we are. I mean, with Graybond able to not just meet, but also potentially exceed the strength levels of cement at a 35% cement replacement rate. When I say exceed the strengths, that offers potential to lower your overall binder use and dosing. So,
because there's a certain strength, once you hit that certain strength threshold, you don't need
excess binder, right?
Okay,
and that plays directly into.
It took me 3 episodes to start to understand what you were actually talking about. This is, I don't know if this is good or bad.
No, that's not bad at all, Jerrod. It took us 5 years to understand.
Oh, there you go. I'm way ahead of you. So, okay. So is that also what you're talking about when you're saying, like, there's a note here. I actually highlighted it. Lab test suggests using optimal admixtures with Graybond binders provides the potential to lower the binder application rate by 10 to 20%.
That's exactly it. Yeah.
Using Graybond. So that's what you're talking about.
Yeah. So refinements. I spoke about refinements, where we were with the first trial, and then how we refined our product, and also the cement substitution target rates, for the second trial. That included the use of admixtures, water reducers, and other admixtures. And that is, I spoke about the strength. I focused on the strength so far. The other major feedback that we got from our partner, mining partner, was that, the handling and workability of Graybond was significantly better compared to cement. So
why is that?
The use of the admixtures and enabled us to use lower amounts of water and yet achieve the same flow characteristics.
I see. Okay.
Yeah. So the combination.
You should just lead with that. We use less water. The whole world will. You'll be on the front page of places. So the actual handling of it was easier as well.
It was easier.
Okay, I want to just before we go on, I want to understand one other thing. When you're talking about this range of cement replacement, Is that because of the curing time as well? So that if you were to, let's say, do 100% Graybond,
Yeah.
that would take a much longer time to cure. So in a lot of applications, that part, I'd never quite put that piece together.
Yeah.
So 100% application, let's say you put it on to, let's say, a foundation, it would cure to the right specifications, but it might take, it would just take way, way longer than 28 days.
Right. Well, I mean,
is that a big part of it?
It is, and I would say it's highly application dependent.
Right.
So in some instances, you're going to get, that's okay. In others, it's not. And that's why
It's like
it's
if you're
all about
reinforcing a road or something like that, then it needs to be fairly quick.
Right, exactly. On the other hand, you're also going to have, we'll talk about soil stabilization and, the other aspect of it. So where, especially when clays are present, you need the lime to actually modify the clays. And so it's a different strength mechanism, strength building mechanism. I'm sorry, what?
I was just thinking, like, if you're doing
your question there.
Yeah, like if you're going here, I want to make sure. So let's say you're doing a backfill.
Yeah.
What you're trying to find out is a big thing is how quick it needs to cure.
Right.
Strength, right?
Yeah,
and that will indicate.
That'll determine how much cement you can replace.
Right. Okay.
Right, yeah.
Yeah. I just never actually had a clear understanding of how you were gauging. And is that the primary driver of how much cement you're going to replace?
Yes, that's right. Yep.
Okay, now let's jump over to this is just me trying to learn. This is the nice thing about long form is you can stumble around a little bit trying to find your way. Let's talk about soil stabilization because that's quite interesting. You've also done some trials there, and this sort of moves Graymont into a whole new space, way beyond mine backfill.
That's right. Yeah.
So how quickly how long have you been with Graymont?
5 years now.
5 years. Okay, so
Correct.
You've been part of the process.
Yep.
How quickly did that discussion start to go, oh, this is for a lot more than mine backfill?
Yeah, that's a great question. So we took away the learnings of mine backfill, and that helped us expand and broaden the uses of Graybond into the construction application. So I'll give you a brief history of how this evolved.
You don't have to be too brief. We got time.
Yeah. Okay. All right. So the two types, I'm not sure if I mentioned this earlier, but the two main types of backfill systems are cemented rockfill and paste fill. So the cemented rockfill, as the name suggests, involves more of a coarser rock type distribution of the backfill, whereas the paste fill is more finer material that you have to stabilize, right? We haven't spoken much about the paste fill, but we also have active, collaboration underway with mining operators to work on binder systems to replace cement and cement slag systems in paste backfill. Now, back to how Graybond was Graybond evolved and transitioned from and expanded beyond mine backfill into soil stabilization. There's parallels to draw between paste fill and the particle size distribution that you encounter in typical soil types. So the soils, the subgrade soils, the native soils that you typically want to improve strength and treat using chemical binders, they're of the similar size distribution and characteristics of paste. So that's how we learned from our R&D work related to paste backfill and develop solutions for various types of soils.
So how does that... Okay, can you walk... I don't know. Soil stabilization is actually... I really know very little about it. So when you're talking... So it's almost... The native soil almost is like... It is almost automatically paste in a lot of cases, you're saying? Or in some applications?
No, there's a resemblance between the paste backfill and the soils. Soil stabilization, you have a variety of different soils, ranging from sands to clays. So depending on the soil type, typically for when you have to build over the soils would need some strengthening and durability using the treatment of chemical binders.
Right.
And that's what typically is done using either cement or lime, depending on the type of soils or a combination of.
How is it actually put onto the ground though? Like, it's not the material, the ground is not turned up, right? Or is it just basically layered over top?
No, it's mixed with the soils
Okay.
in the ground. So you have the binder that arrives at your project site, and then the binder is spread at the target application rate throughout the section that you want to stabilize or treat, and then it's mixed. The binder is then mixed with the soils, and then allowed to cure or mellow for a certain period of time. So you have proper interaction of the binder with the soil. After which, add the right amount of water, of course, and then that's then followed by final mixing and compaction, and using a roller. After which, you with time you're gonna get the strength.
So okay, let's walk. So what kind of results did you get off of that?
So
Or what stage have you gone to market with that? Have you, or where's the stage at? I mean, this will come out probably. I mean, people might be watching this 6 months from now. So
yeah, sure.
But this is, what are we in right now? We're in July.
Yeah.
So as of July, where is that?
Okay. So the development process or the timeline for soil stabilization, similar to mine backfill, started out in our own lab, and then we quickly expanded our network of third-party engineering firms. And did testing to get exposure to various soil types, and also define the optimal blend ratios of Graybond for different soil types. So where we are right now is we've got a good handle of what the optimal blend ratios for Graybond are for different types of target soils.
Okay, sorry, I want to jump in on this. Because I feel like I spent the other 2 episodes not realizing how you were coming to that. Now, I understand that the curing rate for, a mine backfill.
Yeah.
I get that now. But now with these different soil types, how do you choose which is the right amount?
Right. So it depends on the soil composition. So the amount of clay.
This is not a curing.
The curing.
This is a different.
Yeah. So there's 2 components involved here, right?
Yeah.
The first task is to make sure that you come up with the right formulation of the binder, depending on the soil type and chemistry, right?
Yeah.
The curing would be, if you have the right binder, then you should be able to get the required strength in the desired curing time. Right. So in soil stabilization, there's no negative impact of curing time by using Graybond. You're able to achieve the strength targets at the same curing time that you would use for traditional binders.
It becomes not as much the primary as making sure you get the right for just the stabilization.
No, getting the right binder formulation is just as important for any application, including mine backfill and soil stabilization.
Right.
Yeah.
Sorry, what I meant actually though is that it's in this case, so it's really you're trying to figure out what is the right basically mixture to make sure that the end product is at a certain strength.
Correct.
Yeah,
that's right. Exactly. And so I'll provide some background on how Graybond works, and maybe that'll So for soil stabilization, Graybond uses well-established principles of how lime reacts with clays, and which is so lime's typically the preferred binder of choice when clays are present.
Okay.
And the reason for that is clays are a source of alumina and silica, which essentially the clays are high plasticity index, wherein the lime lowers the plasticity of the clays and increases the pH of the soils and breaks down the clays. So it breaks down the alumina and silica and provides the calcium for development of the cementitious products. So the calcium combined with the alumina and silica and right amounts of water is what results in the formation of the cementitious products, which results in the strength gain. Now with Graybond, we're able to broaden the type of soils that can be treated using calcium-based solutions. And this broadens, the type of soils that we can treat with Graybond to more of the silty clays, the sandy silts, and all those soils that may have some clays, but also have silts and sand. So you're looking at a plasticity index, which is typically, used in soil stabilization to define, what the right binder is. Anywhere between 5 and 20, a PI of 5 and 20, is the target PI range, plasticity index range for Graybond. And the distribution of sand, silts, and clays within the soil would determine how much lime, pozzolan, and limestone fines there would be in the Graybond blend that we develop for this application.
I just want to do a little bit of a comparison. So with cement, then, how do they decide? Is it a similar? They're doing a similar thing, but just with, like, let's say they're using Portland cement. It's the same. They're doing the same method, just with a different product. Is that right? If they're doing soil stabilization?
Yeah. So cement is typically used. Cement's typically the preferred binder for treating sandy soils, granular soils. So sandy, lower plasticity soils, right?
Yeah.
And it's just the same one cement formulation that works for a certain soil type. With Graybond, it's an engineered binder. You're able to adjust the composition of the binder to tailor it to perform well with a variety of different soils.
Right.
Yeah.
This must be, just before we actually wrap up the interview, what has been the feedback now? You've had trials.
Yeah.
You're dealing with clients. How far in with soil stabilization? You've had the one trial.
Right. We didn't speak about that much. So
let's get into that.
Yeah. So our first field trial with soil stabilization happened in April, and that was with a large contractor. It was a project in Garland, Utah, where it was a big storage warehouse that they were building, and the soils needed to be stabilized and strengthened before they would construct on top.
Right.
So so this was a trial where the general contractor, the dirt contractor, and the engineering firm, along with Graybond, we presented the idea of Graybond to all of them, and we all got together, agreed on, and there was interest all around to try Graybond, and compare the performance of Graybond against cement in this project. And we ended up working with them to produce about 30 tons of Graybond at our production facility.
30 tons. How is that? I don't really have a gauge if that's a large amount for.
It's not a large amount, but it's sufficiently large amounts for a trial, right? So to put that in perspective, we had 4 test sections, four test sections side by side, 2 that were treated with Graybond and 2 that were treated with cement. And the size of these test sections were like about 12 inches thick, 12 feet wide, and about 160 feet long.
Okay, so
large test sections. So the 30 ton was enough to.
So there's 4 sections, you're saying?
Yeah, four sections, but the 30 tons of Graybond was used for 2 of those 4 sections.
Right. Okay.
At 4% binder application rate. So that's 4% by weight of the soil.
Why the two sections? Why the?
Yeah.
Is it different compositions in the 2?
Right. So no, it's the same composition, but a different binder application rate. So the dosing was different. 2 of the sections were at 4% dosing, and the two of the other sections were at 5% binder application. So we just wanted to get an apples to apples comparison between Graybond and cement, right?
Okay. Yeah.
So think about 4% Graybond, 4% cement, 5% Graybond, 5% cement, and then track performance over time. Right.
And I'm guessing, since you're here talking about it, it was as good or better than the.
That's right. Yeah. That's right. Exactly. So I didn't say that. There was a feedback from the contractors, and we were happy to note that Graybond matched up to cement and bettered the performance of cement in certain instances. Of course, there were learnings from the trials, right? There were we wanted to make sure that in terms of the dosing, the right amount of dosing for the trials, 4%, for instance, was actually the 4% binder sections outperformed the 5%. So meaning for both cement and Graybond. So meaning the 4% dosing was more towards optimal compared to 5%.
So why is that?
That's just a function of how that's the magic that happens in the lab, where you design where you play with the soils and the binders and come up with the right amount of binder. So to maximize performance. So so
the 5% though. So other result, what would be the why? Like, what performance measure makes the 4% better?
It was a function of the in situ soil bearing capacity. Once the sections were treated Then the engineering firm came out and did the DCP testing, which is the dynamic cone penetrometer testing, which gives you a gauge of the in situ soil strength and bearing capacity. So that was the metric that was used to assess or compare performance. And the 4% treated sections outperformed the 5% treated sections. So
it's amazing stuff. It's so fun. These are the kind of interview. The more detailed it gets, the more fun I have on the interviews. Before I let you go though, I was curious. You've been with the project for 5 years. What in the development of the product? I'm not asking for trade secrets or anything like that, but just in the development, what has been either the biggest learning curve or the surprise or just something you didn't anticipate? I mean, you personally as being part of this development.
Yeah.
What sort of stands out to you?
I think the unique challenges that every project presents and understanding, taking a deep dive, working with our customers to find out exactly what they want to achieve, right? Accomplish, and making sure that, we consider all angles, right? We want to make sure that we add value to the project. So adding value comes with answering the hard questions of, what is the business case for replacing cement or, the incumbent binder? How do we add value, right? So coming up with a solution that meets all these needs is the real challenge, and that's where the excitement
is. It more involved? Is it more involved than you thought it would be?
Absolutely, absolutely. It's not. It's never a one size fit all solution, right? So every project is different. Every material that you treat is different. So we come up with creative blends, and that's you adjust the ratios of Graybond. You formulate Graybond, even not just the blend ratios, but also the size of each of those raw materials. Right, so to make sure you have optimum reactivity. So, so every project is different, and that's the challenge. Yeah.
This is just some of my closing questions. To develop this product, what specialties does it take from a team? So you've got, I imagine, like chemists, engineers. What kind of team do you need? Skill sets do you need to formulate to actually get a product like this to market?
Right. So we have a team of scientists and engineers working closely together. I'm part of the marketing team, but not marketing in the typical traditional sense. We focus on, true to my title, new products and applications. So I have a background, a PhD in civil engineering, and we work closely with, and others in our team are also, you have chemists that, pay close attention to of course, doing a deep dive into the overall chemical composition of the binders that we develop, making sure that we use analytical tools like XRD, X-ray diffraction, SEM images to understand what really is happening, how, whether to validate the mechanisms that we hypothesize or propose, make sure that's actually being, realized in the performance of how Graybond works and functions. So it's a team of experts. We have experts within our team that focus on mining, have huge background and experience in mining application specialists. Application specialists, right? A combination of chemists and civil engineers, and also
There must be some over the 5 years. There must be some fun days, like everybody planning out, figuring things out.
It's been a fun ride, and I'm confident that it's only going to get more crazier in terms of
it's clear you're just ramping up, so it's pretty exciting.
That's right. So
thank you so much for coming on, Dwayne. I'm glad to do it in
person.
That last show that you did with us was
back in
SME?
February. Yeah,
that was at SME.
That's right.
That was strapped to a headset with a remote. So this is actually in person. I hope you enjoyed actually coming into our studio. We love having people in here. So
yeah, likewise. I enjoyed the experience. Yeah.
Okay, Narain, thank you very much.
Thank you, Jerrod.
We'll do it again soon.
Yeah.
Take care.
Appreciate it. Bye.
And thank you everybody for watching. We covered a lot of ground. We're going to put links, of course, to Graymont and Graybond specific products. So you can go check that out. Follow them on LinkedIn. Narain, is it okay if we put your LinkedIn if people want to connect directly with you?
That's okay.
Yeah. So we'll have Narain's LinkedIn. You can connect directly with him. And they also have a YouTube channel. So there's lots of ways to sort of interact with Graybond and just learn more about them. Or Graymont, sorry. Thank you, everybody, for watching. We will see you on the next episode of The Construction Show.